All right, in this video, we're going to look at addition in base 10. We're going to come back and look at subtraction in the next video. Okay, let's look at the expanded algorithm. So what happens with the expanded algorithm? It's very similar to the traditional algorithm that we do, except for in this step when we write the answer. So let's look at what's happening here. So with the expanded algorithm, I'm going to start in the ones place, just like I would in the traditional algorithm. 4 plus 3 is 7. Now here's where things get a little bit different. We would normally say 1 plus 2 is 3 and write the 3 here. But the expanded algorithm is going to really emphasize the fact that this is not actually a 1 and a 2. Because of its place value, this is actually a 10 and a 20. So when I add 1 and 2, I'm really adding 10 and 20 to get 30. And then I can add these numbers, which for many students is going to be easier because of the 0 right here. There's no regrouping. 7 and 30 makes 37. So in the expanded algorithm, you add the ones just like normal. You add the tens as tens and put the answer underneath, and then add those two sums together to get the sum of the final answer. Okay, let's look at the addition algorithm that we are more familiar with, the more traditional algorithm, and we're going to look at building that with our blocks. So I'm looking at the base 10 blocks, very similar to what we did in the last video with other bases. 1, 4 is going to mean 1 rod and 4 tinies. It's just that when we do this one, our 1 rod has 10 tinies in it, right? Because in the base 10 system, it takes 10 of these to make one of these. And so that's what I'm illustrating here with the blocks. So 23, exactly what you would expect, 2 rods and 3 tinies. Each rod has 10 tinies, so 23 and 14, and we are combining them to get the sum. Okay, so let's start with the tinies. 4 and 3, when I combine those, I have 7. So over here in my standard algorithm, 4 plus 3 is 7. Now let's add the rods. 1 and 2 more. If I combine those, I'm going to get 3. Over here in my regular standard algorithm, 1 plus 2 is 3. So the way I'm thinking about this here is not necessarily just 1 and 2, because 3 should not be in the tens place, right? 3 would be in the ones place. I'm thinking of this as 1 rod and 2 rods making 3 rods. So one group of 10 plus 2 groups of 10 makes 3 groups of 10. Okay, so what I want you guys to do in your answer, I want you to write for me a part, whole word problem that would go with this equation. And remember, we looked at in the standards that we should have the unknown in all positions. So you could put your unknown as this part, you could put your unknown as this part, or you could put your unknown as the whole. It's up to you which way you choose to do it. So write for me a part, whole problem with one of these numbers as the unknown, as the answer to the question. Okay, let's go back to our expanded algorithm. So this time I'm going to do 37 plus 28, which is going to require some regrouping. So look what happens here. 7 plus 8 is 15. 15 I'm going to write right here, 5 in the ones place and 1 in the tens place. I'm not, even as a small child, that's probably not going to be hard for me because I've been writing the number 15 for a while. Now I'm just putting that in the context of addition. And now I'm going to add 3 and 2, but remember in my expanded algorithm, I'm not thinking about this as 3 and 2, I'm thinking about this as 30 and 20, and 30 and 20 make 50. Okay, so now let's add our two in-between sums together to get the total sum. And again, notice I've got that 0 right there. That's going to help me with my addition. 5 plus 0, 1 plus 6. 1 plus 5 is 6. 15 plus 50 is 65. So this may be an easier addition to do for a child who's struggling because of the 0. This may be an easier addition to do than this one is. So the expanded algorithm with regrouping is good mathematics. It's totally fine to do. And this may help your student who's struggling until they get ready for the point where they're ready to carry over a group of 10 into the tens place. Notice here there's no carrying over, there's no regrouping, because I can put 15 right here and then the 50 is going underneath it, which changes things a little bit. Okay, let's do that same question, only this time we're going to do the standard algorithm and we're going to do some regrouping. So I have built here with our blocks 37 and 28. And you remember when we do addition that we build both of the numbers to start with. So 37 and 28. I'm going to start in the ones place. So I'm going to group together my tinies. And you remember from what we have done in the past is that if I have 10 of them, I have to group them together into a rod, right? It takes 10 of these to make one of these. So I can tell because I have 7, and I know from my make a 10 that I learned when I was in kindergarten, I only need 3 more to make a rod, and this is more than 3. So I'm going to go ahead and I'm going to stack these together into a rod as I'm going. Sometimes your students may not know that and they may have to count until they get to 10 and then be surprised by the fact that there is a rod. Some of them will remember their make a 10 strategy and they'll be able to figure out very quickly that a rod is going to be needed. And it's also okay at this point to have your students group them together and then shove them off to the side and pick up a rod. They don't necessarily have to stack 10 of them and create a rod. It's okay just to pick up one that you might have sitting to the side. Okay, so look what we have here. I have 1, 2, 3, 4, 5, 6, 7, 8. Make a 10. I need 2 more to make a rod. So 8 and 2 make 10. Okay, so now let's write what happened over here. When I combined my 7 and my 8 tinies, I got 1 rod, right? Which we can see that right here. And I have 1, 2, 3, 4, 5 tinies left over. So that's the same 15 that I had before. It's just written differently. This time the 5 is in the ones place and the 1 has carried over to the top so that at the bottom I'm just going to have one final answer instead of having those little in-between sums down there as well. Okay, let's count our rods. So I know, because I'm in base 10, that it would take 10 rods to make a flat, and I have 1, 2, 3, 4, 5, 6, which is not enough. So I'll go ahead and put 6. So the answer to this question using the standard algorithm is 65. And I'm helping my students to figure out what's going on by doing this. So I'm going to ask you guys as an assessment to do some subtraction for me. And I want you to notice really carefully the way I'm doing this. Notice that I always do the concrete first and then the abstract. So I put the blocks together, or if it's subtraction, I take them apart. And then what I'm going to do is I'm going to write down over here what I'm already seeing over here on my blocks. So the blocks are the drivers. They are the ones that tell me what to do over here. It's not the other way around. I don't add abstractly and then show the same thing on the blocks. I use the concrete, I build with my blocks, and then I show that it's the same thing over here abstractly. So start, second step. Okay, let's do this one. 176 plus 127. So I have an addition problem. So you can see I've got all my blocks already labeled out here. 176 and 127. Okay, so the first thing I'm going to do is I'm going to choose to write those in a column format, just like I would want my students to do on their paper. All right, so there we go, 176 plus 127. Okay, so let's start combining. So I remember from what I have done in the past that it takes 10 tinies to make one rod, right? Because I'm in a base 10 system. So I have already 7 right here. It's only going to take 3 more to make a 10, and I have 6. So I know I'm going to have enough to make a 10. So let me just start, putting these things down here. 1, 2, 3, 4, 5, 6, 7. Okay, now I learned in kindergarten about make a 10. How many more do I need to make a 10? If I'm at 7, I need 3 more. So 1, 2, 3. Okay, so I have one group of 10 and I have 3 tinies. Okay, so let's illustrate that over here on my problem. So I have one group of 10 and I have 3 tinies remaining. Okay, so did you guys catch that? I did the blocks first, and then what I did with the blocks came over here into my standard algorithm. Okay, let's combine the rods. Remember, how many rods does it take to make a flat? This is a base 10 number system, so it takes 10 rods to make a flat. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly enough. So let's make a flat. So as I said before, it's not actually necessary that your student very carefully lines up their 10 rods so that it looks like a flat. It's totally good, and it's fine with me when you do your video if you want to just group 10 of them into your hand and trade them out for a flat. You're very welcome to do that, and I'm sure that you would not mind your students doing that, as number one, it's less time consuming than this, and number two, it looks a little bit neater than what I've got here. Okay, so now let's see what happened. I put those 10 rods together and I got a flat, and I don't see any rods remaining. So I have no rods and I have one flat. Okay, so when I add 1 and 7 and 2, you guys remember in the first grade standards I had to add 3 numbers. This is why, because I was going to start regrouping. So I added my 3 numbers together, 1, 7, and 2, and I got 10. But that's not just 10, that's 10 groups of 10. That's 10 rods. So that gives me 0 rods remaining and 1 flat. All right, it takes 10 flats to make a cube. I only have 3. So I don't need to group them up, and I'm going to get 3 right here. 303 is the answer to that question. Okay, so now what I want you guys to do is I want you to write a word problem for this. All right, so the format for a compare word problem, I'm specifically asking for compare right here. The format for a compare problem, this is the first person's things, or the first set of things you have, because this is addition. This second number tells me how many more. So whatever it is you have 176 of, the other person or the other table or the other group has 127 more than you do. And down here, this is how many the second person has. Okay, so this time I specifically want your unknown to be the answer, which means your question should be asking how many whatevers does the second one have. So maybe it's blocks, maybe it's Legos, maybe it's crayons, but somehow you have 176 of something. Then the other person or the other group has 127 more. And then the question is, how many does that second person or group or whatever have? So the question mark is matching with the second, and it doesn't necessarily need to be person. I'll scratch that out. The second thing, whatever the second thing is really what your question is going to be in this case. Okay, so we are going to pause here and we'll pick up with subtraction in the next video.